Hello, this is Mr. Price, and this is the video on showing equivalent fractions for Year 7, Unit 14. The first part is all about representing fractions and some equivalents. So, the first one, I've got my whole area shape. It's been split into 3 equal pieces, so my fraction will be out of 3. The bottom bit tells me how many pieces in total I have. Okay, then the numerator, the top of my fraction, tells me how many of those pieces that I want. So in this case, there are 2 of them shaded, so that is 2/3. The next question is much more trickier because my pieces are not the same size. So the first thing I'm going to do is I am going to cut my piece into equal sized bits. So I'm going to split this into one piece here and one more piece here. Now I'm going to do the same going lengthways. Okay, like this. Now I haven't done that quite accurately because, as you can see, this piece is a little bit bigger. I probably should have done that a little bit further down. Okay, but the idea is still the same. So now I can either count each individual piece. Whoops. So now I can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces, of which I've got 1, 2, 3, 4, 5, 6 coloured in. So 6/15 is a possible answer. Now, you may have also got the number 3/5. This number is also fine. Okay, we're not going to go into too much detail about why this is 3/5. That will come in the next section. Either of these answers are acceptable. Okay, this next question starts to get a little bit more trickier. Now, well done if you noticed that this piece here that I'm colouring in at the moment, okay, I can move it to this bottom piece to make a whole square. So now I've got 1, 2, 3 whole squares, and in total I've got 1, 2, 3, 4, 5 by 3, so there's 15 squares in total. Okay, if you also happen to notice that these red squares can be moved here and here, I can split the shape into 1, 2, 3, 4, 5 pieces, and which I've got 1 of them, so this could have also been 1/5. Either answer is fine for the moment. Now finally, I want to draw lines on this bottom shape to show 5/15. So I want to split this so there's 15 equal pieces. Well, I've already have 3 pieces, so each of these wants to be split into 5 more pieces. So I'll have 5 lots of 3, which is 15. So here's where using a ruler might be quite useful. You can measure it out properly. But here I can split it into 1 piece, 2 pieces, 3, and then 5. Now obviously these are not equal sized, so this is where I would say I haven't done a particularly good job here. You should use a ruler, measure how long this line is, and split it into pieces. So I'm using not the best ruler in the world, so if you measured this, you should have got it to be 5 centimetres. So measure carefully 1 centimetre each, and that will be a much better answer than what I've done. Okay, so here I would not usually accept because they are not equally sized. Same as here and here. Okay, let's look at section 2. So for equivalence, if I multiply the same number or divide the same number at the top and the bottom, I will get an equivalent fraction. So here, to go from 2 to 6, I multiply by 3. So I multiply the 1 by 3. 1 times 3 is 3. here, to go from 3 to 3, I multiply by 1. So, rather pointlessly, I multiply this by 1, and I get exactly the same thing, 3/6. This one is a bit more of an extension. Now, I could try and go from 6 to 7, but that's a pretty horrible sum to do. Okay, it ends up being a pretty annoying decimal. So instead, I'm going to go from my most simplest form, 2 to 7. So to go from 2 to 7, I multiply by a number. Now, if you don't know what that number is, you can divide 7 by 2 to work out what to multiply by. So here, I'm going to do just that on the side here. 2 into 7 goes 3 times. I'll put in my remainder, my dot even, my decimal point, sorry. Put in my placeholder 0. Because 2 times 3 is 6, I'm 1 away from 7, so my remainder is 1. And then 2 into 10 goes 5. So I've multiplied by 3.5. So I multiply the top by 3.5. 1 times 3.5 is 3.5. Okay, let's move on to the next questions. To go from 4 to 24, I have multiplied by 6. So I'm going to multiply the 3 by 6. 3 times 6 is 18. Okay. Here, going from 18 to 12 is a little bit awkward. So instead, I'm going to start with my simplest form. I'm going to go from 3 to 12, which is multiplied by 4. So I multiply the 4 by 4. 4 times 4 is 16. Okay. Finally, using 24 or 16 is awkward to go to 6. So I'm going to start at my simplest form, 4. And now here, because 6 isn't in the 4 times table, I need to do a division sum to help me work out what that is. So 4 into 6 goes once, decimal point, decimal point. 4 lots of 1 is 4, so I'm 2 away from 6. And 4 into 20 is 5. So that's also multiplied by 1.5. So I'll multiply 3 by 1.5. If you're not sure how to do this, I'm going to do 15 times 3 rather than 1.5 times 3. 5 times 3 is 15. 3 times 1 is 3 plus the 1 is 4. And because 15 is 10 times too big, I'm going to divide my answer by 10. So that's going to be 4.5. So that's 4.5 over 6. Final question. To go from 7 to 28, I multiply by 4. So I multiply 3 by 4, I get 12. Here, to go from 3 to 15, I multiply by 5. So 7 times 5 is 35. And now finally, to go from 3 to 1, I divide by 3. So I'm going to do 7 divided by 3. Threes into 7 goes twice. Decimal point, decimal point. Remainder 1. 3's into... that's fine, thank you. 3's into 10 go 3 times. Decimal point. Remainder 1. Now, because I've got a 1 repeated, the same thing again, it's going to keep on going on forever, so that's 2.3 recurring. And that is finished. I hope that was useful. See me in class if you need further help. Thank you.